Hi everyone, we're getting into Chapter 2, Warming and Cooling the Earth and its Atmosphere. We have a lot to cover, so we are going to be covering this bit by bit. When we look at thermodynamics in Chapter 2, we're talking about a study of energy and its transfer in a system. There's some important points there. Energy and its transfer in its system. In the system in meteorology, we're talking about the atmosphere, the Earth's surface, and parcels of air. We represent them in models, like models of balloons. You may ask, what is energy? Move that over here. Energy is heat. We can interchange those two words in science at any time, energy or heat. I like to use the word energy, and I will be using it throughout the course, and I'll be putting heat in parentheses. So energy or heat is a quantitative property, a property that we can measure that moves between objects. The objects that we're talking about in meteorology, again, are the atmosphere, the Earth's surface, and what is in the air parcels, the nitrogen, the oxygen, the water vapor. So it's a quantitative property that we can measure that moves between objects, between the atmosphere, between the surface, in order for the matter in those objects to do work. Now you may ask, what is work? And I'm ahead of you there. Work is, move that over here. Work is a force that causes movement in a direction. Okay? The direction can be up, the direction can be down, north, south, east, west. Work is a force that causes a movement in a direction. You may look at that and say, well, what work is going on in that tornado? That's just destruction. But destruction is also work. Let's talk about it. The work that's in that tornado, and you're going to be studying all of these forces, included forces like the pressure gradient force, the gravitational force, buoyant forces, which you learned a little bit about in Chapter 1, the Coriolis force, centrifugal force, and centripetal forces. There's a lot of force in there on top of friction, and we'll study them all. So destruction is still work. And you may say, just to go back to that definition of energy, you may say, okay, so it is energy to do work, all right? But if you're telling me that energy is heat, then heat sounds like temperature. And is there a difference between that? Yes, there is a difference between heat and temperature. Heat is a property that we measure. It's a characteristic that we measure in objects that are transferring energy and in objects that are moving themselves. And by moving, they are transferring energy. All right? So heat is a property that we measure in moving objects. And temperature is a unit to measure average speed of the particles in any object, moving or stationary. When I am tapping on my screen here, my screen is stationary. It still has a temperature. So temperature is a unit of measurement for the average speed of the particles within my monitor that could be moving or not moving. The monitor could be moving or not moving. The particles are always moving inside of it. The average speed of that is the temperature. So just to give you an aside, inside my monitor, there are plenty of molecules, silicone molecules, plastic molecules, carbon molecules. They are all moving at any time. They could be moving fast if they're in a cold room. They could be moving slowly if they're in a cold room. They could be moving quite quickly if they're in a warm room. So temperature is a unit of measure for the average speed of particles in an object. When I talk about speed, we're actually looking at temperature as a speedometer for particles. You have a speedometer for your car. These are speedometers. Temperature is a speedometer for particles. A thermometer is a device for the units of measure the temperature. Okay, a thermometer is a device. So it is a speedometer for particles. You have a speedometer in your car. And that's a device in your car. This is a device for particles. You can have different techniques to quantify those units of measure, and you can have different methods to quantify those units of measure. You could use Kelvin, you could use Celsius, you can use Fahrenheit. In this course, we'll generally be concentrating on Celsius, but we can't do that all the time because our National Oceanographic and Atmospheric Association, NOAA, uses Fahrenheit for surface measurements and Celsius for anything above the surface. So while we will be concentrating and getting you used to Celsius, we have to use Fahrenheit. Kelvin is another measure that is closely related to Celsius. We won't be using that as much, and I'm not going to concentrate on that right now. Just to go back for a second to Unit 1, and I'm going to move this up so you can see it. Good. In Unit 1, we discussed temperature and altitude. We discussed that as altitude increases, temperature decreases. And here is one of your scales of that. As altitude increases, temperature decreases. And we explained the reason for that. We said that as gravity decreases with altitude, that means that the compression on the molecules in the parcel decreases. That means the kinetic energy of the molecules in the parcel decreases. And since temperature is a measure of energy, that decreases as well. That temperature decrease corresponding with altitude has a rate. It can decrease by a number of degrees per feet or per meter. And that temperature decrease by altitude has a name. It's called temperature lapse rate. You'll hear about that. I wanted to talk to you a little bit more about temperature before I got into it, but that's an aside. Now let's get back to the energy. Getting back to the energy, there are two types of energy. There is, and when we get back to energy, we can get back to heat. There are two types of energy or heat. There is potential energy and there is kinetic energy. Potential energy is when you blow up a balloon and you don't seal it, but you grasp onto it really tightly. And I probably should have a balloon here to show you this. That's potential energy. That's stored energy in the balloon. When you let that balloon go, and it goes all over the room, that is kinetic energy of motion. Okay? So in the atmosphere, there's both potential energy, stored energy, ready to work, and kinetic energy doing the work of motion. An example of potential energy in the atmosphere is a cloud. A cloud like a cloud on the cover of your book is a really ominous cloud telling you something bad is going to happen here. And this has a lot of energy in the cloud with potential to do work. And the work could be the tornado that results as a result of it, the kinetic energy of the tornado. Let's talk about, so we're talking about potential energy here and kinetic energy. Let's start with what you know. You've heard of the word kinetic. You've heard about a kinetic party. It's a dynamic, it's a high-powered event. Kinetic energy is energy of an object in motion, like letting go of the balloon, goes flying off, right? Kinetic energy of motion. There are several types of kinetic energy in meteorology and in atmospheric sciences. Those types include thermal kinetic energy. In other words, the energy of motion of hot air and cold air. Hot air rises, right? Sound energy is the thunder that you hear. Mechanical energy is the wind. We'll learn all about the forces behind that. Electrical energy is the energy of the lightning strike itself, not the energy leading up to the lightning strike. And radiant energy is the energy coming in from the sun. So there's several different types of kinetic energy, and you should know, and this is an important point, that when we talk about kinetic energy, we can talk about temperature and a type of kinetic energy, thermal energy. But let's go back to what temperature is first. Temperature, again, is the unit of measure of the average speed of the particles in the object. And the object can be moving or the object can be stationary. It just so happens that a common unit of measurement of thermal kinetic energy, the energy of movement of hot air and cold air, happens to be temperature. And it is still measuring the average speed of the particles of the warm parcel and the cold parcel. But you should know the temperature can also measure energy in stationary objects. Just happens to be the one that's used for thermal kinetic energy as well. There's a lot of things. What you should remember is meteorology is a relatively young science, and it's advancing quite rapidly now with climate science that is so desperately needed. So you are getting in on the forefront of something that you can work on. These have issues with these measurements. You can be part of the solution for that. This is a new science. That's the end of that. Let's talk about the rest of it on the next lecture.